Hi, we're on the second video, and on this one, this is called Square of a Binomial. It's a special product because you can use kind of a shortcut. Now, if you don't understand the shortcut, you can always write this out as like this first one, x minus 5 times x minus 5, and just multiply it out like I showed you on the previous video. Now, I'm going to show you how to use this formula. So first you kind of identify, right, your A and your B. Right, here's my A and here's my B. And notice on the formulas, they're almost the same except for this sign. And that has to do with what sign's in the binomial that you're squaring. So if it's a negative, then we would use the second one. If it's a positive, we would use the first one. So we're going to use x for A and 5 for B. And then I'll show you how to use the formula. And then I'll also talk you through a different way you could go about this. Okay, so we're going to have, when we write this out, right, we're going to have the x squared minus 2, right, A times B, so x times 5, right, there's my A times B. And then I think I'll put these both in parentheses. Let's do that. So x times 5, there's my A and there's my B, and then plus B squared, which would be the 5. Now notice I didn't put the negative with the 5 because I put the negative right here with the 2, and that takes care of it for this question. I simply simplify that, x squared minus 10x plus 25. Now here's another way that I talk about that. So you can always write it, right? X minus 5 times x minus 5. So here's a way that the same thing. I square the first term. So that's x squared. I take the first term times the second times 2. So x times negative 5 is negative 5x times 2 would be negative 10x. And then I square the second term. Negative 5 times negative 5 is 25. So that's a quick way if you understand this. Now, some students just don't get this formula. They don't like this formula, and that's fine. You don't have to use it, but it is beneficial to learn, because in this chapter and then for the next chapter, when we're going to be doing all kinds of factoring later in this chapter, and in fact we're going to start factoring on the next section, it's helpful when you factor because we kind of go backward from what we're doing. So it is a helpful formula. You might just try it. You know, try it. You might think, oh, this sounds terrible. And then when you try it, it's not so bad. All right, so let's split that off. So I'm going to show you this again. My A is 4x. My B is z. Okay, so I'm going to take a squared, and I'm using the first formula because this is a plus, right? This tells me what to do there. So 4x squared, a squared, plus 2 times a times b, right? Because these are taking the place of the a and the b, and then it's plus the b term squared. And then I simplify, so that's going to be a 16x squared plus 8xz plus z squared. So that's how you apply that formula. All right, let's do one more. Okay, so my A this time is 3y and my B is 1. All right, here we go. So I'm using this second one because of the minus, right? This tells us to use the second formula. So 3y squared, there's my a squared, minus 2 this time because of the minus right here, times a times b, and then plus b squared. So this would be 9y squared minus 6y, right? Because it's just negative 2 times 3 times 1 plus 1. Now, the result that we just got is something called a perfect square trinomial, which we'll be talking about also when we factor. All right, then I have to do my workaround. Okay, so I got my screen back here, and this one is also a special product. It is the sum and difference of two terms. So if you'll notice, the A and the B are the same terms, but except for the sign, right? So the sign changes that. But we have a shortcut here. So when we take x minus 2 times x plus 2, we have a special shortcut we can take, and that gives us an a squared minus a b squared. And then let me just kind of show you this. So my my a in this case will be the x, right? And my b will be the 2. And so it's really just saying I'm going to have x squared minus 2 squared. So x squared minus 4. Now, just like the previous special product, we can take shortcuts here, or we can take shortcuts or not take shortcuts. And so you could just multiply it out. And when you do that, you get x squared plus 2x minus 2x minus 4. These two terms equal 0, and that's why we end up with just x squared minus 4. All right, so we get the same thing as we did when we used our shortcut. Now, I didn't really show you the multiplication on the previous one. I maybe should have done that. I have another one later, so I might show that to you. Okay, so on this next one, my a is 7x, and my b is 9, right? So the formula says a squared minus b squared, and that would be 49x squared minus 81. Most students do pretty well with this this little formula with the difference of squares, so it seems to be one that's easier for them. And then last, here we have my a would be 2/5 x, and b would be 5. So we have a squared minus b squared. Notice I'm just saying minus 5 squared because it's going to be minus 25. So 2/3 squared would be 4/9. So 4/9 x squared minus 25. And that's using that little formula there. Okay, so in this one, I would definitely use the difference of squares to multiply these two first, because if you're multiplying 3, you have to start with 2 of them, right? We can only do 2 at a time. All right, so we're going to take, that's going to be x squared minus 9. And then notice when that happens, now, remember I got the x squared minus the x squared minus 9 because my a was x and my b was 3. So I got that from multiplying x minus 3 times x plus 3. And then because I have the difference of squares again, right, the sum and difference of squares, I'm going to get a difference of squares for my answer. I can do this again. So x squared times x squared would be x to the 4th. 9 times 9 is 81. And then I use that effectively 2 times for this question. Okay, so here's some function work. We're going to work with polynomial functions and multiplication this time. So notice on the first one, we're multiplying the p function, 5x, times the q function, x squared minus 2. So this one's simply distributive property. 5x times x squared would be 5x cubed. 5x times negative 2 would be a negative 10x. And then we don't have any other simplifying we can do with that because we don't have like terms. On the next one, we're taking x plus 5, right, the r function, and we're squaring it. All right, so that's back to using that formula. Or we can just say x plus 5 times x plus 5. So I'm going to show you this the long way, right? X times x is x squared. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. So you recall in the formula, right, we always have a 2 times, plus 2 times this. It's because we end up with two terms that are the same, right? So that would be 10x and then plus 25. So I kind of showed you that the long way. Next, we're going to multiply 3 of these. Okay, so we're going to have the p function times the r function, which is x plus 5, times the q function, x squared minus 2. Now, once again, you have to do these two at a time. You don't really have a choice. So we are going to start out with, I think you can kind of go either way with this, but I think what I'm going to do is keep the 5x and then multiply x plus 5 times x squared minus 2. Right, so x times x squared would be x to the third. X times negative 2 would be negative 2x. 5 times x squared would be 5x squared. 5 times negative 2 is negative 10. And then I simply go through and distribute the 5x. So I'm going to get 5x to the fourth minus 10x squared plus 25x cubed minus 50x. You might want to rewrite this in descending order. So that I would just switch places with my middle two terms. And then we have it written in descending order. And I mean, it's okay either way, really. I went ahead and went with the order that it was when I multiplied it, but then I rewrote it just to get that descending order. Okay, so on this we're going to do that substituting of the a plus h, and then we're going to simplify where we can. Notice the last one is g of a plus h minus g of a, so we're going to have those two answers, which will make the third one easier to do. Okay, so if I find g of a plus h, that means I take the a plus h and substitute it for the x. And then I simplify what I can. Now I'm going to square a plus h. Remember, that's going to be a squared plus 2 times a times the b, right, which is a and h, plus h squared. And then I'm going to have plus 2a plus 2h, and I still have a 1 out there. Okay. So I have a little bit more simplifying. Let's see. Nothing will combine on this one. So I just have a squared plus 2ah is h squared plus 2a plus 2h plus 1. I know this can sometimes be a bit confusing, so you definitely want to practice this concept. And it just, I mean, it's kind of messy, really. Okay, g of a. That was not so bad, right? G of a would simply be a squared plus 2a plus 1. And then I subtract, okay? So I'm going to take the function I found, right, g of a plus h, so I'm going to take this. H squared, I'm writing it all out. And I'm going to subtract this function. I think I'll put this one in parentheses also. So basically I'm just going to go through, I'm not going to write this whole thing out again. I'm going to say plus, and each one of these is going to be a negative. So here's what happens. A squared and a squared and a negative a squared is going to be a 0. I have a 2a and a negative 2a, so that's also 0. I have a 1 and a negative 1, so I have a 0 again. And here's what's left of this. I have the 2AH, and then I have h squared plus 2h, and that's it. That's all I have left. All right, so that's it for this video.